we have talked about all our operations with decimals. So then you can probably figure out what's up next is our operations with fractions. So before we dive into the sections that the book has, we're going to review adding and subtracting fractions and mixed numbers, and then also review multiplying with fractions and mixed numbers. Then we'll get into back where the book is, and we'll get into dividing with fractions and mixed numbers. So example 1, we're going to add or subtract. We need to write our answer in simplest form. Of course, we're going to need to show work. Okay, so the big thing when you're adding and subtracting fractions or mixed numbers is you've got to have a common denominator to be able to add or subtract them. So get a common denominator. Okay, so if I already have a common denominator, awesome, then I just either add or subtract the numerators. The denominator goes along for the ride. If I don't have a common denominator, I need to get a common denominator by using preferably the least common denominator of my two denominators, and then at that point in time, then I can add or subtract my numerators once I get that common denominator and get my equivalent fraction. So on A, I've got 2/3 plus 1/3. I like this question. Both of them are out of 3, so they both have a denominator of 3, which means I can just add together my numerators. So 2 plus 1 is 3. The denominator goes along for the ride, which was a 3. And then 3 over 3, that is not in simplest form. 3 goes into 3 one time, and so my simplified answer is 1. Now, that's the only one we have that already has a common denominator. So B, I've got 5, 6 minus 1, 8. I cannot do this problem until I get common denominator. So my first thing I'm thinking about is what is the least common denominator between 6 and 8? In other words, what's the least common multiple? So what's the smallest multiple 6 and 8 have in common? Now, some people might say, well, can't I just take 6 times 8 and use that? Yes, you definitely can. And sometimes that's what you're going to have to do. But if you always rely on that, you're causing yourself a little bit more work than needed. You're causing yourself to have to deal with bigger numbers. It works, but you are causing yourself to have to deal with bigger numbers, which sometimes can make it a little bit easier to make mistakes. So if you use the least common denominator, that just makes your life easier. So what I noticed is that 24 is a multiple of 6, and 24 is a multiple of 8, and so that's going to be my least common denominator. So I'm going to rewrite these two fractions with a denominator of 24. So I realize that I have to take 6 times 4 to get 24, so then I have to take 5 times 4 because it's that whole equivalent ratio, equivalent fraction thing. What I do to the bottom, I got to do the top. 5 times 4, that's going to make that be a 20. I got to take 8 times 3, so therefore I got to take 1 times 3. 1 times 3 will give me a 3 there. And now I have the common denominator. Now I can just subtract my numerators. So 20 minus 3 is going to give me a 17. The 24 goes along for the ride. And 17 over 24 is, in fact, in simplest form, so I'm good to go. C, I've got 7/9 plus 2/3. Okay, so again, no common denominators. I notice right away that 9 is a multiple of 3. So I'm going to leave the 7/9 as 7/9, and I'm going to rewrite the 2/3 with a denominator of 9 because 9 is a multiple of 3. Well, what do I have to take 3 times to get 9? 3. So then I got to take 2 times 3. So that's now 6/9 as opposed to 2/3. But then now I can add my numerators, and the 9 goes along for the ride. So 7 plus 6, that's going to give me a 13. 9 goes along for the ride. Now, of course, that's top heavy. I'm not going to leave it top heavy. So I'm going to simplify that by saying 9 goes into 13 one time with 4 left over. So I get 1 and 4/9. Take a look at that. Is the fraction piece of that in simplest form? It is, because there's nothing that goes into 4 and 9 other than 1. Okay, on D, now I'm running into subtracting with some mixed numbers. Now, what we're going to learn with multiplying and dividing is that I have to rewrite those as improper fractions or top-heavy fractions, as some people refer to them as. To be able to multiply and divide, I have to be able to multiply and divide. To be able to add and subtract, I do not have to do that. I could do that if I wanted to. There are some minor benefits to doing that if I make them top-heavy, which I'll talk about here shortly on one of the problems we get to. But you do cause yourself to have bigger numbers. So, I mean, there are some benefits, but then there are also some drawbacks. I prefer when I'm adding and subtracting to leave them as mixed numbers. I can do that, so I'm going to leave them like that so I don't have to deal with the big numbers. But I still have to get a common denominator. So this one's 16, this one's 8. I realize I can take 8 times 2 to get 16. So then I'm going to leave the 3 and 15/16 as is. But then I'm going to rewrite the 1 and 1/8 with a denominator of 16. So 8 times 2 is 16, so then I have to take 1 times 2. So 2 And now I can do the problem. So it is subtraction, so I can just go ahead and take 3 minus 1, subtract the whole number piece of it, which is going to give me a 2. Take the 15 minus the 2, that'll give me a 13. Over the 16, the denominator goes along for the right, and again, take a look at it. Is that in simplest form? Yes, it is, because there's nothing that goes into 13 and 16 other than 1. Said had I chose to make them top heavy, I would have still got the same answer in the end, but I would have had quite a bit bigger numbers, right? Because I would have had to take 16 times 3 plus 15, and then 8 times 1 plus 1, and then common denominator. And then when it's done, I'm going to have to turn it back into that mixed number anyways. And so if I can get by without having to make them top heavy, I would rather probably be able to do that in most circumstances. Now, again, like I said, you don't have that option for multiplying and dividing. You have to make them top heavy, but we'll talk about that when we multiply and divide. So on E, I've got 4.5 minus 2 3/4. So again, I don't have common denominators. I realize that 4 is a multiple of 2, so that's nice. So I could take 2 times 2, so therefore I'm going to take 1 times 2. So that'd give me 4, and then a 4 here on the bottom. 1 times 2 makes that 2/4 minus 2 3/4. Okay, so this is that one situation I was talking about where maybe making them top heavy, if you don't like having to do this, might be a benefit to you. If I made them top heavy, if I made them improper, I would not have to do what I'm going to have to do. I would not run into this problem. And so the problem I'm talking about is 4 2/4 minus 2 3/4. I'm taking a larger number minus a smaller number. I shouldn't have any problems with that. But when I go to take the 2/4 minus the 3/4, I have a problem. And some people might say, well, can't you just do 3 minus 2? Well, as we learned when we were subtracting with decimals, right? If it was 0 minus 2, I couldn't just do 2 minus 0. That's not how it works. So then because of this situation that happened here, I'm going to have to regroup. And so that's the same as borrowing. I'm going to rewrite the 4 2/4 so that way I don't have this issue. So I'm going to reduce the whole number down by 1. I said all I'm doing is rewriting it so that way I don't run into this problem. So I'm borrowing from the whole number. So I'm reducing it down by 1, and I'm adding that whole number onto my numerator. So the whole in this case would be the denominator. So reduce the whole number by 1, add the denominator to the numerator. So 4 plus 2, so that will be now 6/4. And if you're not sure if you've done it correctly, just think about it. Is 3 6/4 the same as 4 2/4? Yeah, it is. I just rewrote it a different way. And then now I don't need to do anything to the 2 3/4 because that's not what was causing me the problem. The problem was that 4 2/4 and trying to subtract the 2/4 minus the 3/4. Now I don't have any problems. 3 minus 2 is 1. 6 minus 3 is 3. The 4 goes along for the ride. My answer is 1 3/4. Now again, like I said there is one little benefit if you were to write it top heavy. If you don't like doing that, then maybe an option for you would have been to turn this into these into improper fractions, so that way I didn't have to deal with what I just had to deal with. Okay, but again, like I said, causes some bigger numbers. F, I've got 5 1/6 minus 4 5/8. Again, no common denominators. I'm trying to figure that out. If I use my resources, we already said the common denominator between 6 and 8 was going to be 24. So I already realized I'm going to rewrite that with a 24. So it'll be 5 and something 24ths minus 4 and something 24ths. 6 times 4 is 24, so then I have to take 1 times 4. So that'll be 5 and 4 24ths. 8 times 3 is 24, so then I have to take 5 times 3, which would make that 15. Now again, looking at this, I run into that same problem, right? It doesn't always happen in subtraction. Just like when you're subtracting with whole numbers or with decimals, I don't always have to borrow. I sometimes do. But here I run into that problem again. 5 and 4 24ths, it's bigger than 4 and 15 24ths. But the fraction part of it is not. 4 24ths minus 15 24ths, I'm going to run into a problem there. So I'm going to regroup again. I'm going to reduce the 5 down by 1. It's going to be 4. Add my denominator to my numerator. So 24 plus 4 is 28 over the 24 minus 4 and 15 24ths. And now I'm not going to have that problem. 4 minus 4, that's 0. 28 minus 15, that's 13. Now, of course, if I have 0 and 13 24ths, that really means I just have 13 24ths. And is there anything that goes into 13 and 24 other than 1? No. So my answer is, in fact, in simplest form.